Hi, Mark Granis here with section 8.2, Conditional Syllogisms. This is the second part of chapter 8 on compound syllogisms. And we will begin, as we normally do, with a recap of what we learned in our previous session. Then I will introduce the first of two different kinds of conditional syllogisms, the mixed conditional syllogism. We use that to discuss the phenomenon of arguing forward and arguing backward, the constructive mood and the destructive mood, and that will lead us into a discussion of what the valid and invalid moods are for mixed conditional syllogisms. Once we've done that, we can very quickly go through the second kind of syllogism that we'll discuss today, the pure conditional syllogism, and we'll discuss the valid and invalid moods for pure conditional syllogisms. So let's get started. In previous episodes, we learned what a compound proposition is. It's a proposition that comprises two or more different categorical propositions in some logical relationship to each other. So, categorical propositions, one subject and one predicate. Compound proposition has two of those in some logical relation. What kind of logical relation? Well, we've discussed three. It could be an if-then relationship, which we call conditional. It could be an either-or relationship, which we call disjunctive. Or it could be a both-and or a not-both-and relationship, which we call conjunctive, or sometimes a negated conjunctive. It is this logical relation that tells you what kind of compound proposition you have. So you might have a conditional proposition, which is a compound proposition in which two categorical propositions are joined in an if-then relationship, right? It's the same definition that we have up above, except that we've specified what the kind of logical relationship is. The other thing that we discussed yesterday was that we can write the conditional proposition as if P, then Q, where P and Q stand in for entire propositions rather than just terms. So we've previously used those letters to discuss, to stand in for terms in a categorical syllogism, but when we get to the conditional proposition, we use P and Q to stand in for the entire categorical proposition. Having done all that, we were ready to get to the overall point of this entire chapter, which is the compound syllogism. It's a syllogism in which the major premise is a compound proposition, and the minor premise might be either compound or categorical. So, a syllogism, just like other syllogisms, 3 lines, and the conclusion purports to follow from the first 2 lines, which are premises. But the difference here is that the major premise, that is the first premise, is a compound proposition rather than a categorical proposition. And then the minor premise could be either one and the conclusion could be either one. All right, let's look at the easiest kind of mixed conditional syllogism. Here is the mixed conditional. Here's the definition. I'm going to warn you in advance. We'll go over it, but it's not the easiest way to learn this. But I promise you I couldn't make it any simpler. The mixed conditional syllogism is a compound syllogism in which a conditional major premise and a categorical minor premise lead to a categorical conclusion. Blah, blah, blah. It's hard. It's much easier to understand what this is by looking at one. Here's one. If it's Sunday, then Chick-fil-A is closed. It is Sunday. Therefore, Chick-fil-A is closed. That is a mixed conditional syllogism. If we try to write it out symbolically, we get something like this. If P, then Q, where P is, it is Sunday, and Q is, Chick-fil-A is closed. Then, in our second premise, we say, P, it is Sunday. And for our conclusion, we say, therefore, Chick-fil-A is closed, therefore Q. Now, when we write it this way, P is known as the antecedent. It's the part that comes before the then and after the if. Q is the consequent. It's what follows from the antecedent. And you may recall that this is the general pair of terms that we use for all deductive inference. It's true of all deductive inference that the consequent follows from the antecedent whenever the inference is valid. And so the if P then Q uses that same terminology. Note, however, that there's nothing special about P and Q. We could say if A then B, if X then Y, if J then K, or even if A then Z. And any of that works. We're simply using some symbol to stand in for an entire categorical proposition, And one of the reasons we do that is because it gets us away from the matter of the argument and helps us focus on its form. We're still doing formal logic. All right, so what's this about arguing forward and arguing backward? Let's look at our example again. If it's Sunday, then Chick-fil-A is closed. It is Sunday, therefore Chick-fil-A is closed. This is an example of arguing forward. And I think maybe the best way of understanding the difference between arguing forward and arguing backward is to think about the four different things that we can talk about here. We've got P or not P, Q or not Q. Well, what can we tell if we know that it's Sunday, and what can we tell if it's not? And what can we tell if we know that Chick-fil-A is closed, and what can we tell if we know that it's not closed, that it's open? Well, if we know that if we know that it's Sunday, then we can know that Chick-fil-A is closed. But what if we know that it's not Sunday? Can we know anything? Can we know that Chick-fil-A is not closed? No, we can't know that. There could be lots of reasons why Chick-fil-A is closed. It could be Christmas Day. It could be 4 a.m. There could be a boil water alert in the area. For all those reasons, Chick-fil-A might be closed, even if it's not Sunday. All right, what can we tell if we know Chick-fil-A is closed? Can we tell that it is Sunday? Well, no, we can't tell that it's Sunday because, again, for the exact same reason, there could be lots of reasons why Chick-fil-A is closed. It's not exclusively because it's Sunday. It's necessarily because it's Sunday, but not exclusively. Well, what can we tell if Chick-fil-A is open? That is, if it's not closed. Oh, well, if it's not closed, it must not be Sunday, right? That seems to follow. So of the four things that we can do, either affirming or denying P or Q, two of them help us know something else, and two of them don't help us know something else. How do we know all that? We take the logical relationship from the major premise itself. The major premise tells us that if P is true, then Q must be true. So if we affirm P in order to affirm Q, this is called arguing forward, because we move from P to Q, or the constructive mood, because we are moving by affirmation rather than denial, or in the shortest and most widely accepted term, modus ponens. Even people like me who don't know Latin, if they've studied logic, they know what modus ponens is. Here is modus ponens written out symbolically. If P, then Q. P, therefore Q. That's modus ponens. And it's absolutely valid. And it's valid no matter what P is and no matter what Q is. If the premise, if P then Q is true, then the conclusion Q must follow from any assertion, from a true assertion of P. Okay? Now, what about arguing backwards? Well, by contrast with this, we argue backwards whenever we start by denying the consequent. In other words, we're starting at the back of the if P then Q statement and moving toward the front. This is also known as the destructive mood or modus tollens when we're moving by denial, right? And moving back from the back to the front. It looks like this. If P, then Q. Not Q. That squiggly line means not. Chick-fil-A is not closed. Therefore, not P. It must not be Sunday. And that also is completely valid. Absolutely valid. So we can go ahead and use either one of these, modus ponens or modus tollens. So why are we making this distinction? Well, because you can't mix and match. Modus ponens and modus tollens are both valid moods for mixed conditional syllogisms. But modus ponens proceeds forward by affirmation, and modus tollens proceeds backward by denial. If you mix these two things up, you get invalid moods. So remember, there were four things we could do. We could affirm P, and that told us something, or we could deny Q, and that told us something. But we don't get anywhere by denying P or affirming Q. Here's an example. If P, then Q, Q, therefore P. So if it's Sunday, then Chick-fil-A is closed. Chick-fil-A is closed, therefore it must be Sunday. Wrong. We discussed this. There are other reasons why Chick-fil-A could be closed other than it being Sunday. So we can't make this inference. Similarly, If I know that it's not Sunday, in other words, if P then Q, not P, therefore not Q, that also doesn't work. And these two don't work for the exact same reason. There are other reasons why Chick-fil-A can be closed other than the fact that it might be Sunday. So these are actually two famous fallacies. They're so famous they get their own fallacy names, and we'll use these again when we deal with other kinds of arguments. The first one is called affirming the consequent. Q is the consequent. If you affirm Q, that tells you nothing. That's a fallacy. You can't get anywhere by affirming Q. And the second one is called denying the antecedent, because P is the antecedent. And so if you try and proceed by denying P in order to deny Q, you're committing a fallacy. That is an invalid mood. So of the four different ways that we could proceed with a mixed conditional syllogism, here they are, and this table is just taken straight out of the book, right? Modus ponens and modus tollens are both valid. That is, we can argue forward by affirmation, that's modus ponens, or we can argue backward by denial, that's modus tollens. What you can't do is argue backward by affirmation, this is the lower left-hand quadrant here, or argue forward by denial. That doesn't work. Those are the fallacies of affirming the consequent or denying the antecedent. All right, so that's the mixed conditional syllogism. What does the pure conditional syllogism look like? It's a compound syllogism in which both premises and the conclusion are all conditional propositions. Here's an example. If capybaras are mammals, then they're warm-blooded. If capybaras bear their young alive, then they're mammals. Therefore, if capybaras bear their young alive, then they're warm-blooded. If we try to write that out symbolically, we get this. If Q, then R. If P, then Q. Therefore, if P, then R. So note that this starts to look almost like, a little bit more like the categorical syllogisms, namely in that we have something, this Q here seems to look almost like a middle term. And indeed, we do need it to function that way. If I said if Q, then R, if M, then N, well, that wouldn't do anything for us because there's no link up there. So we do need, in the first two propositions here, we do need to have there to be some connection there, just the same way that we do with our middle term in the categorical syllogism. But then, in the conclusion, we would say this is modus ponens because it points toward an affirmation of P as a way of affirming R. Right? So if you look at the conclusion of a pure conditional syllogism, then you can tell whether it's modus ponens or modus tollens by seeing whether it's moving from one of the from the earliest antecedent to the final consequent, or whether it's moving in the other direction. We can also use modus tollens, also valid, and that points toward a denial of R in order to deny P. So for example, if Aslan is an animal, then he stays dead when he's killed. If Aslan is an ordinary lion, then he's an animal. Therefore, if Aslan does not stay dead when he's killed, then he's not an ordinary lion. This is what that would look like symbolically. If Q, then R. If P, then Q. That's exactly the same as what we have up above. But now in the conclusion, instead of saying, therefore, if P, then R, we're going to say, therefore, if not R, then not P. In other words, if the final consequent of all of this is false, then we know that all of the things leading up to that can't be true. We'll be able to deny the earliest antecedent by working backward by denial. So that means that the conditions of validity here for the pure conditional syllogism are going to look reassuringly just like the conditions of validity and the moods of validity for the mixed conditional syllogism. We have modus ponens and modus tollens. We can work forward by affirmation or backward by denial. But on the invalid row, we cannot work backward by affirmation. And on the right-hand side, we cannot work forward by denial. Those are the fallacies of, respectively, affirming the consequent and denying the antecedent. All right, well, that'll do it for this session, and I'll be back next time with disjunctive syllogisms.